Hello, y'all. Welcome to lesson 137 of my DP chemistry curriculum. Today we're going over reactivity 3.2.11. This covers a reduction of unsaturated compounds by the addition of hydrogen that lowers the degree of unsaturation. Sorry, I'm just going to fix that here. So we're going to do some products of the reactions of hydrogen with alkenes and alkynes. So let's just quickly go over what an unsaturated compound is. We've talked about these before, but basically it's any organic compound that contains at least one double or triple bond. So like alkenes and alkynes. These are going to be unsaturated compounds. Furthermore, what we can do is called an unsaturation test. And this can be on compounds that we're not sure if they're unsaturated. And generally, this is done by the addition of bromine water to a solution of hydrocarbons. If you think back to electrophilic addition, what we're really just doing here is halogenation. So this is electrophilic addition. We can see it in example if we're taking something like ethene, C double bond C with two hydrogens, plus bromine. Now, ethene is colorless, bromine is brown, and through electrophilic addition, what's going to happen is we'll break that double bond and end up with 1,2-dibromoethane. Now, 1,2-dibromoethane is also colorless. So that allows us to see if something's saturated or not. Just by adding some bromine and looking at the color change, we can kind of see whether or not it is unsaturated. But generally, when we refer to these, what we're actually looking at is the degree of unsaturation. The degree of unsaturation is basically a test where we use hydrogen, and we specifically look at the number of hydrogen molecules needed to saturate a compound. So like one double bond is done in by one hydrogen molecule. A triple bond needs two. This process is called hydrogenation. So hydrogenation is adding hydrogen to reduce a compound. We can see this here if I do another example using the same ethene. So C double bond C only needs one hydrogen molecule to turn into ethane. And so that would be hydrogenation. So one thing to note is during hydrogenation, it doesn't happen as quickly or at room temperature. Generally, the process of hydrogenation actually requires a metal catalyst and a high temperature and pressure. So like, for example, this could be done with nickel at 180 degrees Celsius, and that would start this reaction. So we need that high temperature to break these bonds and actually start this reaction because this is not an electrophilic addition reaction, unlike the halogenation in the previous example with the bromine test. A couple other things is that often the metals that we use for this could be Common ones you'll see on the DP exam are nickel, palladium, and platinum. Those are going to be the very common ones you see that act as catalysts for this. So I mentioned that this is not electrophilic addition. This is just reduction. So what we're looking at, and remember, reduction can be the addition of hydrogens to lower the oxidation state of that carbon. Philic addition. So while you can try and figure out the oxidation state of the overall compound or of the carbons, like we'll note right here, if we just look at ethene right here, we have carbon and it's bonded to two hydrogens. These will both be +1. This carbon has a -2 oxidation state. Now, when it's bonded to bromine, which I missed the R there, but two hydrogens, which are +1, the bromine, which is -1, this only has a -1. So it's actually oxidized in the presence of the halogen. But other than counting the oxidation states and looking at the addition of hydrogen, another way to tell the difference is, well, reduction is always going to reduce the carbon. But in electrophilic addition, we're going to end up adding a functional group. So the examples were with like a hydrogen halide is going to make a halogenoalkane. A halogen is going to make a halogenoalkane, and water is going to make an alcohol. So we're going to end up creating a functional group within electrophilic addition, which is a little different than reduction. So it really depends on which molecule you're adding to your hydrocarbon to determine whether or not you're doing reduction or electrophilic addition. And once again, reduction, the key components here are degree of unsaturation and the actual oxidation state of those compounds, as well as the uses of metal catalysts and high temperature and pressure is need to be known. I hope this helps and have a great day.